Section 4.1, Polynomial Functions. What we're going to do here is first look at leading terms, leading coefficients, the degree of a polynomial, and do some classifications. The degree of a polynomial, let's look at this one first, is just the highest exponent. So the degree on this one would be 4. Leading term is just the term that that highest exponent is on. In the case of this first equation, the leading term is 4x to the 4th. Leading coefficient is just the numeric part of that term. In this case, the leading coefficient's 4. You're also going to run across these terms: constant, linear, quadratic, cubic, and quartic. All this refers to is the degree of the polynomial. Constant is a polynomial degree 0. In other words, y equals some number. Linear, the exponent is 1. Quadratic, exponent is 2, or degree is 2. Cubic, degree is 3. And quartic, degree is 4. So this particular polynomial would be a quartic. And note, the degree of the polynomial refers to the exponent of highest term, not the location. So in the second example, that is going to be the leading term, negative 6x to the 4th. This polynomial is degree 4. Leading term is negative 6x to the 4th. The leading coefficient is negative 6. Next, we're going to look at endpoint behavior. And endpoint behavior refers to what the polynomial does as it gets toward plus or minus infinity. In other words, I don't care what's going on close to the y-axis. I just care about what's going on out here and out here, when x approaches negative infinity and when x approaches infinity. And to figure that out, all you're going to look at is the leading term, and you're going to consider two things: whether the leading coefficient is positive or negative, and whether the degree is even or odd. And then you have to memorize 4 things. The first thing that can happen is you have a positive leading coefficient and the degree of the equation is even. And when that happens, your endpoints kind of go off in these directions, or as x approaches negative infinity, f of x approaches infinity, and as x approaches infinity, f of x approaches infinity. And if you're still a bit uncertain on f of x, just replace that. That should be in approaches. You can replace the f of x's with y's if that helps you get a better idea of what's going on. And examples of this type of equation: anything with a positive leading coefficient and an even degree. The next thing that can happen is we have a negative leading coefficient with even degree, and when that happens, the endpoints drop off like this. Or as x approaches negative infinity, f of x approaches negative infinity, and as x approaches infinity, f of x approaches negative infinity. And that's going to happen whenever we have a negative leading coefficient and an even degree. The third thing that can happen is we can have a positive leading coefficient with an odd degree. And when that happens, the endpoints kind of diverge like this, and as x approaches negative infinity, the function values approach negative infinity, And as x approaches positive infinity, so do the function values. And that's going to occur anywhere you have a positive leading coefficient and an odd degree. And the last thing that can happen is we can have a negative leading coefficient and an odd degree. And when that happens, we just take this one and kind of flip it around. So as x approaches negative infinity, the function values approach positive infinity. And as x approaches positive infinity, the function values approach negative infinity. And an example of that is anytime you have a negative leading coefficient and an odd degree. And we're only concerned with the leading term here. We don't care about the rest of it. Okay, the next type of question you're going to be asked is you're going to be given some function and you're going to be given some number and asked whether or not it is a zero. These are fairly straightforward. All you're going to do is plug 4 in for x. Plug that into your calculator, and if you get a 0 out, the answer is yes, it is a 0. If you plug the number in, say 5, and you do not get 0 out, then the answer is no. This type of problem is just this simple. Don't make it any harder than that. And the last thing you're going to cover in this section is zeros and multiplicity. Hopefully you already know that zeros are just where we cross the x-axis, and they're the same as x-intercepts. And when we're factored in nice linear forms, it's easy to find the zeros. For instance, I have a 0 at 0. I have 1 at 3, I have 1 at -1, and I have 1 at -2. The new term here is multiplicity, and that just means how many times each 0 occurs, which really just means look at the exponent. For instance, the multiplicity of 0 is 2, the multiplicity of 3 is 5. The multiplicity of -1 is 4, and the multiplicity of -2 is 1. And the most important thing about multiplicity for you is it determines what happens at that 0. If the multiplicity is even, the graph will bounce off at that point. In other words, at 0 and at -1, if you looked at the graph, what the graph would do is come down to that point, touch 0 momentarily, and then bounce off, reverse direction. If it's odd, it crosses. In other words, at 3 and at -2, where I have odd multiplicity, the graph will come down and go through the graph at that point. So if it's even, the graph touches and bounces off. If it's odd, it goes through the x-axis at that point. Now let's try to find the zeros and multiplicity of this one. Well, this one isn't factored, so we're going to have to do that ourselves. And whenever you have 4 terms, think factor by grouping. And remember, because we have a negative here and we put these parentheses around, that negative has to distribute to both of these, which in effect changes that from a positive to a negative. And now I just look at this and see if there's any common terms I can pull out, and I can pull an x squared out. And there's nothing I can pull out of here. But now each of these terms has an x minus 9, which leaves me with x squared minus 1. And we're almost done because this will also factor. That's a difference of squares, and that factors nicely. And now I'm completely factored. So my zeros are 9 with a multiplicity of 1, a 1 with a multiplicity of 1, and a negative 1 with a multiplicity of 1.